Welcome to The Explainer. Today, we're diving into a chemical mystery, one that's hiding in plain sight, inside some of the world's most gorgeous gemstones. It's as beautiful as it is, well, completely unexpected.
I mean, have you ever really stopped to think about it? What gives a ruby that deep, fiery red, or an amethyst that stunning royal purple? Well, believe it or not, we're about to uncover the secret, and it's probably not what you're thinking.
The secret. It's a tiny chemical flaw. Yeah, you heard that right. The very thing that makes these gems so breathtakingly beautiful and valuable is, when you get right down to it, an imperfection, a glitch in the system.
Oh, okay, so to really get our heads around how these amazing flaws can create so much color, we gotta start at the beginning. We need a baseline. Let's look at what a gemstone is like when it's totally 100% chemically perfect.
So at their heart, gemstones are crystals. The best way to think about this is like a perfectly organized Lego set. Imagine every single brick is exactly where it's supposed to be, creating this super orderly, repeating pattern that just goes on and on. Perfect structure.
All right, let's use a real-world example. Quartz. It's one of the most common minerals on the entire planet. And chemically, it's about as simple as it gets. It's just silicon and oxygen. That's it. Bonded together in that perfect, rigid pattern we were just talking about.
Now, when you have that quartz structure and it's totally pure, we're talking no other elements sneaking in, nothing messing up that perfect pattern, light just zips right through it. It's completely clear, like glass. We actually have a name for this pure stuff, rock crystal.
Okay, wait a second. If a perfect crystal is clear, then where do all these amazing colors come from? Well, this is where a little chemical flaws make their grand entrance. And trust me, they change everything.
There's a great scientific term for this. It's holochromatic. It literally just means other colored, which is perfect, right? Because these are the gems that get their color from tiny, tiny amounts of outside elements, what we call impurities that kind of sneak their way into the crystal while it's growing. They're the little disruptors in that otherwise perfect system.
So let's jump back to that Lego model for a sec. Think of that impurity, that trace element, as one single red Lego brick that got swapped into a giant wall of all white bricks. It's just one tiny change, but it completely messes with how that structure absorbs and reflects light. And that change in light, that's what our eyes pick up as color.
And this is where it gets really mind-blowing in the real world. So you take that clear, colorless rock crystal, right? You introduce just the tiniest bit of iron, I'm talking a few atoms scattered around, and bam, it turns into this deep, gorgeous purple amethyst. It's the exact same mineral, but we see it as a completely different gem, all because of that one little flaw. Okay, so now that we've got that idea down, let's use it to uncover what is honestly one of the biggest secrets in the gem world. This is where that whole impurity creating a new identity thing gets taken to a whole new level. We're going to look at two of the most famous gemstones ever. I'm talking about the ruby and the sapphire. You know them. One is this symbol of intense passion, that deep, blazing red. The other is all about royalty and wisdom in that brilliant classic blue. I mean, they look and feel like they couldn't be more different.
They've got different colors, different names, totally different stories behind them. So they must be different minerals. That just makes sense, right?
Well, the stunning truth is, no, they're not different at all. In fact, chemically, they are almost identical. They're just different colored versions of the exact same mineral. The mineral is called corundum. Its basic chemical makeup is just aluminum oxide. And here's the real kicker. Just like our pure quartz, pure corundum on its own is, you guessed it, completely colorless.
And this right here is where it all clicks into place. They're both corundum. They have the same chemical formula. So what's the difference? What separates a red ruby from a blue sapphire? It's just the impurity. A tiny bit of chromium sneaks in, and you get a ruby. A little iron and titanium get in there, and suddenly, you have a sapphire.
Because of this, the rule in the gem world is actually super simple. If a piece of corundum is red, you call it a ruby. If it's any other color at all, I'm talking blue, pink, yellow, green, whatever, it's a sapphire. So sapphire is kind of the catch-all name for any corundum that isn't red.
So this all leads to a really fascinating final point about what we find valuable. We know the colors come from these chemical flaws, right? But it turns out that the specific type of flaw also decides how rare a gem is and, yeah, how much it costs.
Turns out the geological conditions you need for chromium to get into corundum and make a ruby are way, way rarer than the conditions for iron and titanium to make a sapphire.
And because of that simple fact, high-quality rubies are just so much more valuable than sapphires. In fact, a fine ruby can be one of the most expensive gems in the world, gram for gram.
So what's the big takeaway here? It's that in the world of gemstones, beauty literally comes from imperfection. These little chemical accidents are the whole reason we value them. They take something common and turn it into something precious. And hey, as a bonus, they're also super durable, a 9 on the Mohs hardness scale, which is second only to diamond.
And that leaves us with one last thing to think about. In geology, pure is plain. It's colorless, but a tiny little imperfection, a flaw. That's what creates priceless beauty and incredible value. It's a pretty powerful idea, isn't it? That sometimes the most amazing things aren't the perfect ones, but the ones that are, well, perfectly imperfect.